Good evening, everyone. You are all very welcome to this evening's MU Live. We're going to be looking at everything engineering and robotics related. My name is Fionnuala Finnegan and I work in the admissions office at Maynooth. I am the, student recruitment officer. And I'm joined by my dear colleague, Deirdre Carroll, who's the student recruitment advisor. And we're so lucky this evening to have Mr. John Dooley, who is the assistant professor in the Department of Electronic Engineering and Robotics at Maynooth, and Ciara MacDonald, who is a PhD student at Maynooth. She has completed, believe this or believe it not, a total of 10 years at Maynooth. Such is her love and graw for the institute that she is remaining steadfast, and she's currently doing a PhD. She's going to talk to us about her experience on the undergraduate program, on her master's, and what she's doing on her PhD, and all of the lovely work experience that she's had in the meantime. So we really are very lucky this evening to have such a depth of people to talk about the industry with us. The session is being recorded, so if you know of anyone who perhaps really wanted to be here this evening but just hasn't been able to make it in the end, you can let them know that it will be available online. So where you register, mu.ie/MU Live, and it will be there from tomorrow afternoon on. I'm just going to draw your attention quickly to the bottom of the screen where we have a chat function. Deirdre is going to pop in any useful links for you this evening. They'll go into the chat box. We also have a Q&A, so we hope that you have lots of really good questions for us as we go through, and I can pose them to the panel then, either through the event or afterwards, whichever suits best. So that's it, guys. I'm going to continue talking. I'm not continuing, I'm going to stop. I'm going to do the opposite. I'm going to stop talking and I'm going to hand you over to John, who will give you the presentation. So thanks a million, John. You could take it away.
Thanks a million, Fionnuala. Hopefully I'm not on mute. Okay, so just to welcome everybody to Maynooth University. My name is Dr. John Dooley. I'm an assistant professor in electronic engineering, and Ciara MacDonald is one of the PhD students in the wireless systems group. And she's kindly offered to answer some questions in terms of, as a recent enough undergraduate and having done postgrad studies in Maynooth also. Mainly what we'll talk about is the undergraduate programs. I'll mention some of the main points about postgraduate studies in Maynooth, but I suppose what I was challenged to do was explain some of the career paths. And I think that's probably, in terms of choosing a program and choosing an institute to do the program in, it's very good to have an idea of where you want to get to after the 4 or 5 or sometimes more years. In terms of Maynooth, we've got a number of different avenues: electronic engineering, engineering science, and robotics and intelligent devices. And what I would generally say in open days is that you may actually have a career path in mind, and you could actually probably achieve that career goal going any one of those routes. So MH 304, 201, and 306, I believe, are, basically a tier 1 option to enable you to get onto the career trajectory that you want. Just as an introduction, my first computer looked something like what you see on top of the screen. So, it was a game changer when computers started to turn dark gray, but we used to have a nice kind of bland beige color to begin with. Mobile phones looked something like on the right-hand side. So they had physical buttons that you pressed and a kind of a dot matrix almost display. 56K, which seems unbelievable now, but that was as fast as you could surf the web. And really, at the point at which I was choosing to go to college, the ICT era really had just started making these products available. And this was where all of these products became mass marketed. And fast forward a couple of years through doing an undergrad and a postgrad in UCD, I've gladly ended up in Maynooth University, first as a postdoc and now more recently as a lecturer. I suppose a controversial character at the moment, Elon Musk, but an interesting quote which I came across was one which was reported to have said, "But I don't spend my time on pontificating about high concept things. I spend my time solving engineering and manufacturing problems." And I suppose if you're one of the wealthiest people in the world, it's nice that they've actually quoted engineering as one of the reasons why they've probably made such a success of their endeavors. So first with PayPal and then Tesla and SpaceX. And I suppose that was one of the main points that was raised a number of years ago on Open Days, was that the largest percentage of millionaires in the world are actually engineers. So the top 7 degrees that make the most millionaires, and I have a link on the next slide from where I received this source, but engineering tops that list. And it's not just from one source, but there's a number of sources. If you look at the 22% of the world's top billionaires or top 100 billionaires are engineers. So Larry Page, from co-founder of Google, Jeff Bezos, obviously from Amazon, Carlos Slim, who's a Mexican entrepreneur, multi-billionaire, and he did civil engineering as his primary degree. So a study from 2014 also led to 56% of engineers believe they will become millionaires at some point, and 69% say their role is recession proof. And I think in terms of establishing some of the career paths or the jobs that you might target or your students might target, the recession proofing is key, because as we look at robotics and intelligent devices, there's a certain number of careers now that will probably become obsolete in the future. But then there's also going to be a huge range of new careers opening up. And I suppose, again, with Maynooth, the challenge that we have is to try and create the best, or help to adapt the students to become the best engineers out there. So innovation is key to this. A quote from Stephen Roberts: "Art without engineering is just dreaming, and engineering without art is just calculating." So, you know, I mentioned about my first mobile phone and what it looked like, and you can kind of see on the chronology there, like exactly where that mobile phone sits. So it's about the 3rd one in. But as we see the evolution of mobile devices, you know, what's going to come next? And that's really what we want to start inspiring our students to actually investigate, but starting from the fundamental knowledge. So the key competencies or core competencies of maths, physics, and the science subjects, digital signal processing, throughout all of the different programs that we've mentioned, these are all taught in the modules. One of the common answers about 4 or 5 years ago is, oh, you could make, you know, a watch that was also a mobile phone. And we've seen Apple do that. We've seen a number of other manufacturers also creating devices such as this. But if you look back in time, the original ideas for a computer on a handheld device, you know, if you look back to 1985, Seiko had come out with the first computer watch. Timex, and then IBM, they put a Linux operating system or a Unix operating system on a watch in 2000. And then we see, going to more recent years, you know, that it's been around at that point for decades. So the ideas that we're using in some of the research projects now, they were the original ideas or concepts came from the 1930s. But it's only now that we've actually shrunk circuits down to a size, got the power consumption down to a level that's manageable, and we're actually making full use of those original ideas. And with quantum engineering now sort of becoming more and more popular, it's concepts like that that will lead to the next wave, the next revolutionary ideas. And that's what we can start to inspire our students with in Maynooth. So starting into kind of, I guess, commonly spoken about areas such as, in this case, we have advanced driver assistance. So any electronic features that would appear on motor vehicles to either initially make the job or the life of the driver easier, inform some maybe local authority or national body about the status of the road network. And ultimately what we would like to get is a combination of those two, plus the cars being able to drive themselves autonomously. Within achieving that, you know, just even from driver assistance, adaptive cruise control, emergency brake assist, pedestrian detection, collision avoidance, all of these tools or new features within motor vehicles, they will require electronic circuitry. And I suppose what I'm trying to get the point across here was that in a lot of open days, I've discussed, you know, the motivation for students or prospective students about joining an engineering course. And a lot of people wanted to do mechanical engineering, but when I kind of talked a bit more about it, really what they wanted to do is work with cars. And what I would just try to advise is that in the future, you're going to find an awful lot more electronics. Like even now, you've got electric motors in motor vehicles, no longer internal combustion engines. So this is, I suppose, one of the major areas where we're going to see an awful lot more adoption of these intelligent systems. A cousin of mine who had done a master's in Maynooth was working in a company most recently. He's over in the UK at the moment, but it got me even excited talking to him when he told me that one of the latest projects is on a heads-up display for motor vehicles. So on a car, instead of having the dials below the steering wheel, as you can see there, you'll have them projected onto the windscreen so that you could see the speed on the windscreen. You might also get your GPS directions projected onto the windscreen. So it would be more akin to like a fighter plane, with that you'd actually have all of the instructions on the windscreen as you're driving. What this will allow you to do also is that if you have infrared cameras on the front of the car, you could project the view of the road behind fog. So if you had dense fog or smoke on the road, you would be able to see past the fog and smoke, and you'd actually be able to see. So this would greatly help a driver avoid collisions, especially, you know, in adverse weather conditions. I mentioned intelligent road networks, so there's links at the bottoms of each of these slides where you can navigate to websites. But you know, it's not going to be too far into the future where we'll have cameras on overpasses on the motorways in Ireland, counting the number of cars, estimating roughly the speed, not to act as speed cameras or for law enforcement, but basically just to inform, you know, if you have autonomous vehicles in the future and somebody sits into a car and types in where they want to travel to, the road networks need to inform the cars where is busy. And if you have up-to-date information about the status of the roads and the volume of cars on the roads, this can greatly help. And these types of systems, what we do is in the PBL modules within Robotics Intelligent Devices, in second year, we can actually implement these types of algorithms on a Raspberry Pi. And this article that's referenced shows how you could count cars in less than 10 lines of code using Python. So now obviously there was a hell of a lot of work done prior to that and in the background, but with a very kind of low effort in terms of the coding, it would be possible to actually come up with a car counting system. It seems like we're constantly talking about cars, but I promise we'll by diverging a bit more now. But looking at some of the key technologies, radar, LiDAR, cameras, long-range radar, ultrasonics, these are all fundamentally based off electronic engineering systems. So the electronic hardware is based on RF and microwave engineering, optical engineering, telecommunications, vision processing, digital signal processing, and intelligent control. And all of these are core modules within the EE program and mostly within the Robotics and Intelligent Devices program as well. My main research area is on wireless communications. And if we look at a map of Ireland going from 2G to 3G to 4G, so this was from today, and I went to the Comreg website, and you can see the link at the bottom of the screen. And that website, you can map what the current coverage is for any of the network operators. And you can see going from left to right that the shading there is getting an awful lot lighter. It's not too bad around towns and villages, but when you go to the rural areas, it's getting a lot lighter. And we can see from the legend at the bottom left of the screen, that's where it's the wireless coverage is getting weaker, or not. You don't have the same data rates in those areas. So what you're really looking at there is, right, if I have an autonomous vehicle and I'm relying on that autonomous vehicle being able to communicate back over the cloud to actually retrieve new information about the road network, or to actually, some of the new business models for cars would be that your car might be equipped with a camera, and if you upload images from your car's camera, you actually get to reduce the cost of your car over time, so that the car manufacturer will pay you for the images that you collect as you drive around the roads. But if you can't upload them, maybe you can't make money, or you can't offset the price of your car. So the issue of pervasive coverage and cellular network coverage around Ireland is something that we're interested in looking at. But it's a huge problem because there's a whole other business case or aspect to all of this. So within Maynooth, in second year for the problem-based learning, and within the second year, within the second year of electronic engineering, you do actually start to explore some of these business cases. Or if you develop a new product, you have to start to consider what might be the bill of materials, how might you market it, and the presentation and soft skills that you learn are really valuable then for your future career. The same with wireless networks. On one hand, we're saying, right, we want them completely on the whole time, covering the whole country. On the other hand, what's the point in leaving them all on at night time when nobody's using them? So, in the wee hours of the night, if there's very few people using the mobile phone network, but the mobile phone network is going to consume a huge amount of energy, should we really be leaving it on? Should we not be conserving energy and ultimately reducing our carbon footprint? So on the far left, we can see this is a view from, now it's a number of years ago now, in the mid 2010s, but that's a map of, you can see all of the cell sites in Ireland for one of the main network operators. And you can see the concentration of base stations around Dublin. There's very few around the Wicklow Mountains, just south of that. But then Cork, Limerick, Galway, you can see dense areas of base stations. And the point would be that, well, in those areas, we probably have adequate coverage at nighttime that we can turn half, maybe 3/4 of the base stations off and consume power, conserve power that way. I did promise I was going to show a lot of different future career paths. So there's a company just down in Cork called Collins Aerospace, and I recently met an engineer from there. So he's a team lead, but they're looking at electric motors for airplanes. This is a hybrid electric version from the Collins Aerospace website. But you can see now that the future of air travel, it kind of only makes sense that it might actually go electric also. But there's an awful lot of constraints with electric motors for aircraft because of the power or the energy that's needed to actually fly a plane and transport such a large number of passengers in the air. There's also a ton of ancillary jobs that are going to, and systems that are going to be needed. If you look at the size of this plane, it's quite small compared to probably a 737 that would be commonly used by Ryanair. And short haul flights are going to be within the range of these planes, but you're not going to have the volume of fuel that will allow you to circle around an airport when you get to London, for example. So to schedule flights so that you leave Dublin, you fly as straight as possible, and you land as quickly as possible at your arrival or your destination. That's the objective for future air travel. And those intelligent algorithms to schedule flights, to deal with any delays that crop up during a schedule, even to the extent where we might actually see regional airports around Ireland becoming much more popular. And maybe people are going to be, booking autonomous vehicles to pick them up at the airport when they arrive. So all of the machine learning that's going to be needed to basically orchestrate all of those systems working in harmony is also something that we focus a lot on through the maths and programming courses that we do in Maynooth. On the airplane theme, there's also the within the next 10 to 20 years that we might go to single pilot cockpits, so that the co-pilot might be, if the single pilot was in distress, that the co-pilot on the ground could take over. So, obviously, I suppose the co-pilot in this, or the pilot, sorry, in this, isn't wearing the uniform or standard uniform of an airline, but the concept would be that you would have a single pilot that would have as many features as possible on the aircraft to make their job possible to achieve as a lone pilot, but that there's the redundancy for a backup if needed. In the past, what we've done on the research side is we've actually flown a helicopter at over 20 kilometers and achieved 1 gigabit per second link back to the university. I just mention things like this because it's not just all vaporware. It's not just websites that we look at and come up with the ideas of what might be possible in the future. We've actually got active research projects which inform then the teaching. So when we actually fly a helicopter and we have an antenna inside the helicopter pointing back to where the arrows point into the top of the engineering building, we can tell straight away if something's plausible or not. We've done it in real life. So in this case here, we managed to fly the helicopter as far away as the toll booth on the M4, and it was able to sustain 1 gigabit per second link. And then some of the current research projects that we're doing, one is with SFI, and it's called Co-Pilot AI. And what that's trying to do is to allow ground crews and air crews for forest fire fighting in Ireland. So coordination of the communications there is key, but you can't communicate reliably or, in those rural areas with a cellular coverage that might not exist in those remote areas. Internet of Things is another huge area. Again, the core of that industry is going to be wireless communications. On the top right-hand side, we have an Internet of Things circuit. What we've got is ultrasonic sensors in that case, but the concepts that these circuits could enable is, if we look at in Dublin City Corporation, the bin that's in the center of the view there, a bin like that costs about 1,200 euros, but the electronic component that you could put on the top of it to measure the level of rubbish might only cost 20 euros or 30 euros in larger volumes. The issue is that if you can measure the level of rubbish, you could schedule bin collections. You could schedule bin collections around the traffic management, so that if you know what streets are busy and you can just leave the bin for one day that it's nowhere near full, then you could maybe cancel that from the collection route and move on to the next one on the next street, which is less busy. You'll save tons more petrol. You don't need as many trucks, and it's going to be far more efficient. In the same way, even though An Post has a legal obligation to visit every post box once a day, but if you could tell whether somebody had posted a letter in a post box or not, the post worker would know whether they had to collect post from that post box or not. And obviously in the bottom right-hand corner, a hugely important one, which is that if you have any antisocial behavior where people steal a ring buoy or throw it in the river or the sea, or if they steal the rope from it, that an alarm could be raised, somebody could react to that. And basically all of that could be done extremely cheaply in the future. Kira is currently working on this, so she would definitely do it more justice than me. But one of the other projects that we've got an active research project on is optical wireless communications. And essentially what you could envisage is you could have LED light bulbs in your home or office, and you could be surfing the web by using a light detector on your mobile phone to actually detect the signal from the light bulb, and that's what's communicating or allowing you to have a link to the internet. And you know, in terms of looking at the science behind it and the maths, it, you know, there's again the link for the article is referenced down below, but you can see that it's plausible. We've seen it in practice, and something like this, if the commercial argument could be made right, will sorry, if the commercial arguments can be made correctly, could be another major industry in the future. And almost finished on this section is just that historically about half of NASA's astronauts came from an engineering background. So what I'm just trying to say is that all of the routes that you could take through Maynooth to get to a very fruitful career, you know, are there, and even being an astronaut is not beyond the realms of possibility. We're preparing graduates for what is 1 to 10 years away from commercial release and beyond. And that's ultimately that we've got research-informed teaching across the department on wave energy, so renewable energy, on wireless communications, on biomedical systems. So there's a you know, a wealth of research projects that are feeding back into the teaching. And it's also helping us to prepare graduates, you know, that they have a view as to what to expect when they go out. We also, sorry, I mentioned a couple of those companies, but the work placements in 3rd year or 4th year on some of the programs are invaluable then for students to get experience for after college. So in terms of, I suppose, clarifying, an engineer sits somewhere between a scientist and a technician, where a scientist is generally involved in the discovery of a new technique. The engineer would basically find the best use of those new techniques, and then the technician would implement them on a day-to-day basis. So the design part in the center really involves creativity, problem solving, and technological awareness, and an ability, I guess, to speak to both the scientists and technicians. As a result of that, what we within Maynooth, problem-based learning was really targeted to provide our graduates with the skills. So the 15 skills most employers wanted to see: engineering knowledge, communication, planning. There's very few, there's nothing like digital signal processing is not listed there. Control theory is not listed there. It's all what you would kind of assume would be just a good employee anyway. But in a lot of other programs, I suppose these soft skills are not really pulled out of the undergraduates as much as in Maynooth. So with problem-based learning, what we do is we challenge them within teams of students. They have to work cohesively over a longer period of time. It doesn't work that they just, we tell them what they need to know, they memorize it, and then, you know, give it back to us in an exam paper. What we do is we assign a problem to a team. They have to identify what they need to know. They have to go and learn what they need to know, apply it, and solve the problem. And then they have to communicate the results in a report, because the marks that they get are in a video, a report, and a presentation. And that's all of the communication that they would need in future in industry. Other opportunities that are kind of extracurricular would be Robo Aaron, who just recently, Rudy Villing was managing the team, who's another academic in electronic engineering, and they came 3rd overall in the RoboCup German Open replacement event. So this is, you know, it's one of the unique features about the program in Maynooth. So between electronic engineering and robotics intelligent devices, there's been some very successful teams over the years, and it's unique to Maynooth within Ireland. We also partake in the ESB Intercolleges Challenge annually. So just this year, the team that we put in, it's mentored by me in engineering, and then various academics in the School of Business, and they won the best commercial solution which was to come up with a means of storing a huge amount of energy. So renewable energy that's generated on the grid, how can you store it to power the town of Athlone for a week? So how can you store that volume of energy? And the methods that the team came up from Maynooth won the best commercial solution. So what I would just say is that those extracurricular events, they also require the teamwork. They also pretty much get the best people from the PBL groups taking part in them. And those students are the ones who always go on to achieve the best kind of, I guess, career prospects afterwards. So the typical final year projects, which we target more for the students to actually carry out by themselves or individually, it's car counting for road networks, real-time robotic soccer ball tracking, ECG brain-computer interface, electronic purification for the third world. So there's a large number of projects which are which have a real-world application and could actually directly lead on to possibly even a commercial business afterwards. So within Maynooth, no matter which of the three programs you choose, there's relevant technological knowledge. So electronic circuits, electromagnetics, physics, and signal processing and information management. Various programming languages, creativity and problem solving, importantly, communication skills and business awareness. Just to kind of spell out we had electronic engineering, engineering science, and robotics and intelligent devices. And very often, the electronic engineering and robotics intelligent devices is a straightforward enough one for people to that they're more familiar with. With engineering science, what we're providing in that is a combination. If somebody wasn't 100% keen on just doing electronic engineering, there's the opportunity to choose MH201, and that you could choose the 2 electronic engineering modules in first year, try them out, but also choose possibly chemistry. And we know then from different things like battery technologies that there's many applications of chemistry and electronic engineering. Similarly for astrophysics, so you can see a satellite dish there, a satellite actually orbiting the Earth, and how you actually communicate between the two. But then if you were more interested, to learn more about also on the astrophysics side, so if you wanted to do radio astronomy, you could learn those skills as well through physics, and it would be, I guess, enhanced then with the electronic engineering modules that you could do as well. And similarly, there's electronic engineering and computer science is another route through the engineering science option. So in short, for the undergraduate undergraduate programs, you've got the BE in electronic engineering, so 4-year bachelor's or 5-year master's degree, where you've got a unique blend of engineering and some kind of computer science as well. There's a 6-month work placement opportunity in 3rd or 4th year to create a portfolio of projects. And so you also create a portfolio of projects throughout. So like I said, that employers will like to see not just exam results, but that you've had to do projects over a longer period of time with other people, so that you're good at teamwork, but you can deliver on a long project on time. There's excellent facilities and friendly learning environment across all of the programs, and the entry routes into electronic engineering, and there's some transfer routes as well, but the CAO points into 2021 were just 351 points. The only issue there was that there needed to be a H4 in mathematics, so higher level 4. Similarly with engineering science, the points last year were 401, and with robotics and intelligent devices, so MH306, there's also the possibility for 6-month work placement. You also get the portfolio of projects, and the points last year were 362 points, and there's an O3 or H7 mathematics requirement for entry into that program. So When I mentioned the transfer route, with robotics and intelligent devices, there's a fairly straightforward progression from year 1 to year 4. In the Bachelor of Science, so the engineering science route, you can transfer after first year. Now, the requirement though is that there is a 50% maths requirement for your first year maths results. But the benefit of transferring into the engineering degree program is that there's the opportunity then to do a 5-year master's course, but the 4-year or 5-year exit routes, they're accredited by the Institute of Engineers of Ireland. So it's an accredited course or program. And what that allows you to do is that if you did want to work globally, it's a recognized qualification then. So if you go to the States or across Europe, that accredited course is recognized. And just to note that for year 2 of the engineering science to transfer over to the Bachelor of Engineering, the only requirement is that there's the greater than 50% maths. So in summary, I suppose what you need for going directly into the Bachelor of Electronic Engineering is 351 points, or with the, apologies, I think it's H4 in maths. And then there are 3 exit routes. So there's electronic engineering with computers, electronic engineering, and then electronic engineering with communications. And those options can be selected in 4th year. The Bachelor of Science Engineering, or Bachelor of Engineering Science, is 401 points, and the Bachelor in Science of Robotics and Intelligent Devices is 362. We have in the past received a large amount of research funding from various funding agencies, so that there are opportunities to do masters by research and full-time and part-time structured PhD routes. So I know Kira's been on a structured PhD, and she's very close to finishing now. And what I would say was that we do recruit a number of our graduates, so there are opportunities. What we found in the last couple of years, our master's class are pretty much all hired shortly after Christmas. So the full cohort of master's students generally get job offers, if they've applied for jobs, get job offers shortly after Christmas. So a choice for a career in electronic engineering or robotics and intelligent devices, there's just so many new combinations of hardware and software and business opportunities. There's very many exciting career opportunities in non-traditional areas. And as I said, the degree that you would exit with is a very strong one. It's extremely in demand, and now especially leads to well-paid career opportunities in Ireland and globally. And if anybody would like any further information about this, please don't hesitate to contact us. We have an open door policy. So the phone numbers, postal address, electronic.engineering@nu.ie, and my email address is readily available from the department website, but it's just if you contact the admin office at that email address, if you have a specific query that's maybe in like ocean or renewable energy, they can direct it then to a more suitable academic directly. And yeah, sorry, there should be a thank you slide there, but it's just the image must be too big. So just thanks a million for your attention, and don't hesitate to contact us if you have any questions.
Thank you so much, John. That was absolutely amazing. And I've a couple of questions that have come into my mind, but I'm very conscious that Kira has also given over her time. And also for the first time ever, we might attempt this and hopefully it goes okay. I can see that someone, a participant in the audience, has their hand up. Now, typically we would just have encouraged people to pop their questions in the Q&A or the chat, but oh, maybe it's gone. Maybe that was an error. I might have frightened the person away. Oh, that's a shame. I was going to enable him to talk. Apologies, Derek. I might have scared you off. So never mind. I have one tiny question before we hear all about Kira and her experience, if that's okay. The little robots playing the football, John, does the university construct these from the very beginning, and how does that work? How does that come about?
Yeah, so well, no, the robots, in order to have the international competition, that there's a standard robot that all teams buy. But that's the really interesting part. In first year, we have a make block kit for the first year robotics students, and we provide exactly the same kit to various teams, and they come up with completely different solutions. And they might look quite similar structurally, but one of them will complete a circuit in half the time of another team's robot. So the Neo robots, those small humanoid robots, that's one of the categories for the RoboCup. And so they're humanoid robots, and ultimately they have constraints in terms of the amount of memory, the amount of processing capability. So you have to train them to do things as a team, to identify where the ball is. So, right, that's a round object, that's a different color. But then you have to start to identify, if you see one line, but how do you know, is that the end line? Is that your own end line? Is that the sideline? Is that the edge of the box? And you have to then start to cram in all of this intelligence into a very confined processing engine and memory. And then you have to get all of the robots, because you can't touch them once you set them off to compete. So they all then autonomously go out as a team and play against another team that has been trained by another set of humans from another institute. So it's
fantastic.
Yeah,
it's amazing. Yeah,
it is.
And we came third.
Yeah, in that there was no competitions for the last since 2019. But
was that because of COVID?
I suppose one of the other cool things with that team, I haven't got to go yet. I've just been helping them with kind of ancillary tasks, but the students and the managers get to go to like the likes of Sydney, Japan, so Australia, Japan, China. There's various different locations, and it would have been in Germany then this year. It's
great. Thank you so much for clarifying.
Yeah,
it's amazing. Kira, thank you so much for waiting patiently there. Can you talk to the audience a little bit about your journey to engineering? How did you know you would like the subject? Is this something you've always thought about in secondary school? Did you come to an open day and just happen to chat to someone who inspired you? How did it work? How did the spark ignite in your mind for engineering?
So I was always interested in secondary school. I loved creativity, I loved problem solving, I loved maths. And like that, I went to an open day and I talked to one of the lecturers, and basically it just went from there. And I knew engineering was something I wanted to pursue. So I ended up doing the MH304. So that's the kind of the general entry route. And then you decide in fourth year, because I didn't know exactly what type of engineering. I knew I wanted to be electronic engineering, but I didn't know if I wanted to specify in telecoms or computers or just a general, basically.
Electronic, yeah.
Yeah. So, and 10 years later, here still I am.
Very good. They must be doing something right. Was there a particular area of the course that you really loved at undergraduate level? And did that kind of inspire then your master's and PhD? You could talk to us a little bit about the fact that actually you started off in a different PhD route and then you ended up where you are.
Yeah. So going back to the undergrad first, the one thing I really loved is the work experience. So the way it worked out for my year is I actually got to go on work experience twice because they were transferring over. So I went in third year and fourth year, and I worked for a company called Analog Devices, which is a multinational company in Limerick. So basically, I got to do a ton of work there that I wouldn't have gotten to do in the college. But then the college was very good at facilitating the interviews, applications, getting there in the first place. But I got to do multiple demonstrations. I worked with a product group that did CAN, so it's controller area network. It's basically how planes communicate, the internals of the plane communicate with each other.
Wow.
So I got to do some demonstrations that they had exhibitions in Germany. I got to do that twice. I also got to write application notes for some of their basically how-to guides for some of their products. And then data sheets, which is basically specifying product characteristics. So I got to do a lot of work, and then obviously teamwork, collaboration, time organization, kind of transferable skills that you don't really get from going to university, apart from in PBL, as John pointed out. But yeah, it was a very, very good experience.
Were you lucky enough to have that in person, Ciara? Was that pre-COVID?
Oh yeah, this was 2014, 2015.
Okay.
So yeah.
Excellent.
So, and then that gave me the opportunity to do my project within my master's with industry. So I continued the work again into my master's, and that was my final year project.
Were you still linked in with that company?
Yeah. I got to loan some of their boards. It gave me more resources that might not have necessarily been able to access here. But yeah, it was very, very rewarding and very, very insightful.
Very good. So you completed your 5 years, and then how did you decide on your PhD route? Because I know you made sort of one decision, and
so this is actually my second attempt at a PhD. So the first PhD I did was in biomedical engineering. I always knew I wanted to do biomed or telecoms. So the opportunity arose for the biomedical, but unfortunately my supervisor left for another university, but I wanted to stay in Maynooth because I just love the atmosphere, working environment, the staff. So I stayed here, and then actually John and Ronan, Professor Ronan Farrell, an opportunity came up to work for Nokia Bell Labs in Blanchardstown, and it was based on light, and I just had to go for it. It was something out of a sci-fi movie, and it's something I couldn't pass on it. It was just
when you say sci-fi movie, what talk about your day-to-day, because I'm ignorant.
Yeah, no. So basically, I'm in the lab right now. So I'm surrounded by oscilloscopes, power generators, spectrum analyzers, a lot of equipment that's we're all allowed to access. And yeah, it's something I always wanted to do, but I wasn't sure I'd be able to kind of obtain. And Maynooth University, they've allowed me to pursue this route, which I'm very grateful for it, to be honest. So so I work on Li-Fi. So I generate signals that light bulbs would be able to use to send data to a receiver, maybe in the phones in the future. And basically, while you're walking around your room, your light bulbs would basically be providing you with the data rather than like a Wi-Fi router.
Wow. So these light bulbs do not currently exist, do they? You're creating this capability within the light bulb.
So we wouldn't be using typical light bulbs because they don't flicker fast enough. The data rates we need to go on and off very, very quickly. So it's actually something called a VCSEL. It's an up and coming technology, again, the next 5-10 years that would be in the market.
Are we going to have strobe lights in our houses?
That's the good thing about it. You won't even notice. It's flashing so fast.
Oh, thank goodness.
That it's indetectable for the eye.
Wow. Okay. Yeah. Because I'm not a fan of the strobe light. It just, even at concerts, I have to close my eyes when the strobe light thing comes on. I don't know what it is. I must have a sensitivity to it. Thank you so much. That sounds so interesting. And are you near completion?
I am. I'm hoping to finish now in September. That's the goal.
Wow.
Yeah.
So fingers crossed.
And then you're going to have to cut, or are you, the proverbial umbilical cord from Maynooth, or are you looking for a venture to remain at the university?
What I just say, I just say that the in terms of what Ciara's achieved, like, it's just exceptional. So she'll have no shortage of offers, I'm sure, before September, in terms of future job offers. But it's just the interesting thing is that the most recent graduates, I know Ciara's on a WhatsApp group with people that are in Ericsson, so there's people gone to Ericsson in Sweden, Qualcomm in India, Finland, and China. There's a lot of our alumni then, and then there's a couple in Dublin and Cork. So
because I suppose it depends on what your specialization is in your final year. And then in your master's, does that depend on then where you might get your job opportunities at the end, John?
Yeah, that's it. That there's but even as kind of there's so many transferable skills that she's learned over the PhD and through the undergrad that like the Canvas stuff that could be automotive, aeronautical, then like this digital signal processing, and then digital implementations. You could take your pick of any of those electronic applications. So yeah, I think Kira is an ideal example of when Maynooth University gets engineers right.
Yeah. Do engineers have a typical personality type? Like, if there were people here on the fence, what kind of advice would you give to people who were considering joining the electronic engineering or the robotics degree? Do you have to be a particular type, or
no?
Can anyone just an interest and a motivation, like anything?
An interest. I think no matter what program you choose, like it could be law, it could be business, it could be engineering, or robotics. There's going to be bad weeks or months possibly in your program. It's going to get a bit tough at times, but I think that definitely engineering is a bit more involved with, like I said, those projects, having to work with other people. It's all of these things. It pays off in the end, and I think that's we've got graduates from here. We had a spell of graduates from the postgrad who they all became bankers. So they're all investment banking, risk analysts. Then there's other people then doing machine learning for network optimization.
Wow.
It basically opens up so many doors, because it's not just the transferable skills for other electronic engineering applications, but it's also banking. Even in the class that I graduated with, people were leasing airplanes. There was any number of people in project management consultancy companies. It just the opportunities are endless.
Wow.
And I suppose there were two things that I've kind of learned over the last 5 years as well. Engineering, when it's easier to teach an engineer economics than teach an economist electronic engineering. And so as the first degree course, electronic engineering is good to do first, because you can always branch off easier into some of the other fields. The other thing was that some of the computer science people won't like me for saying it, but it's like the future of computer science really now seems to be like electronic engineering, because in terms of programming languages, there's a lot of learning to do in terms of programming, but in terms of how you structure code, it's and for a lot of the staple programming languages, it's fairly well understood. But if you actually want to accelerate the execution of that code, it's changing the electronic circuits that it runs on. That's where you'll get the best benefits. So if you want to execute trades from London to New York or Chicago faster, it's faster by a couple of, I don't know, is it nano or milliseconds, but to use a fiber optic link with satellites than to use the fiber optic link that's going across the Atlantic or under the Atlantic.
Mm-hmm.
So, engineering has, or the skills that you learn doing engineering or robotics just leads into just so many career.
Diverse, yeah. Kira, I think, mentioned right at the outset of her, just her chat there, that when she was in school, she knew about herself that she liked problem solving, she liked mathematics, and was a creative person. So maybe at a very simple level, a lot of engineers might have these typical kind of personality traits, or maybe not. How did you? Are there any societies with the engineering? Is it easy to make friends? Because I suppose you're all into like-minded stuff.
Yeah, Kira, if you want to answer that one.
Yeah. There's an engineering society, so it basically undergrads run it. So all of the chairman, or what's it called, publication, or basically PRO. That's the one. Yeah. Sorry. All of the seats are held by students, and it's run by students. And it's, I think, very easy to make friends. So in engineering, I mean, the workload is quite heavy.
Okay.
I mean, I compared my sister, she did a different program at Maynooth University, and I think she had maybe 7 or 8 hours of actual in-person learning a week. Engineering, I think I had up to 36 hours at one point. So, but at the same time, it's such a small group that you get to know everyone becomes your friend. And yeah, I think it's a very, very easy place to make friends, especially if you're all creative, problem solving, you're same goal, basically.
Same goal. And as well, I suppose, John mentioned group working. Yes, go ahead.
It was just to say that in terms of within the department, we're not the biggest department around, but it's we do have like table quizzes with staff and students. There's a pool competition. There's a soccer tournament, which somehow the staff managed to win the odd time, but I think it's just because the students just feel sorry for us. And so, you know, and as Kira said, it just, I think quite unlike some of the other places that I've worked, there seems to be a pretty good atmosphere among all of the students, you know, so.
Great. It's collegial and friendly.
Collegial, exactly, yeah.
Yes, and you can have a bit of fun at the same time as taking things seriously, because obviously 35 to 38 contact hours is a lot. It's a heavy workload, but I suppose you've a lot to get through. Individual projects, group projects, all of that kind of thing. How would you attribute your success? What's the key to, you know, succeeding year on year and staying at university?
For me, sorry.
For Kira, yeah. You're the student.
Oh, yeah. So, yeah, motivation, it comes in waves, but I think remembering the end goal is a good way to look at it. But yeah, it's just surrounding yourself with like-minded people, others that want to succeed. And for the majority of my undergrad, I was surrounded by people like that. So we took it very seriously. But again, we had fun. We were able to laugh and enjoy ourselves. And yeah, it's just I suppose, again, going back to that, I love creativity, problem solving, and all the modules that I kind of did, bar one or two, they kind of highlighted those parts of my personality that I enjoy doing. So,
yeah. Thank you so much. A question has come in. I'm so excited. If anyone has any other questions for our panel, please do pop them in. So how would one go about finding funding for small engineering projects? Does the school support the students, or would you have to go outside of school? That's an excellent question. Yeah. I don't mind who answers that, folks.
What I'd say is that depending on the scale of the project, so for very small projects, relatively small, like things like for final year project, we'd have, if I had 4 students and 3 of the students didn't need any funding, if we had on average 100 euros per student, then we could put 400 euros towards one of the final year projects. If you wanted more than that, then there's Spur Funding, which is essentially funding for summer jobs. So you could basically get funding to work over the summer months with an academic member of staff and then pursue an engineering project like that. If it had a commercial viability and if you could convince funders, there's any number of places like the County Enterprise Boards, Enterprise Ireland, and if you, I suppose the excellent thing within Maynooth as well is that the university doesn't take a commercial interest in any undergraduate or taught master's projects. So the commercialization office manage all the IP agreements and obviously, yeah, commercialization agreements with industry or any other outside bodies, but they even had a competition pre-COVID where the bursary was up to 6,000 euros, where students could propose ideas and be put into this competition. And I think there was 6,000 euros, 3,000 euros, and 1,000 euros prize money for first, second, and third. So, you know, there's, I can't promise that's going to happen next year, but you know, there's many. I suppose the trick is actually finding out about those competitions, you know. But I think there's within Maynooth, we're very blessed, I think, with the research office that we have, with the commercialization office, and with all of the admin staff, that it's just you included, Fionnuala, obviously.
Thank you very much.
But it's just that you know, everybody's just a quick phone call away. And yeah.
Excellent. We have another one here. Do you choose whatever you want for a project, or are there set ones? And do you have any examples of any kind of projects that you were do? I suppose we're chatting about undergraduate level here.
Yeah. In terms of the first year and second year projects, typically with first year, we like to structure it in that we would set it so that there wasn't too much variation. It's kind of by second year, we would encourage students, if they did actually come up with an idea for the project, you know, even what we tried to do is that it might be fairly loose in terms of, I had a project for even first year, which was to develop an enclosure that you could control the temperature in. But, you know, the students could decide like what material to use, what size to make it, what way to control it, how to generate the heat, how to generate the cooling, or, you know, enable cooling. And you know, they could take it off in any number of directions. One year people made a greenhouse or glass house. Another year people made it completely a completely light, impenetrable, insulated box. And so in terms of proposing their own project, I know Kira mentioned that after the summer job, you can propose your own final year project. And if you're smart about it, if you've done the starting work, so your literature review and the initial investigation during your summer work, you could spend the months throughout the year actually refining it and getting far further along than you would have by starting in September or October. So in that case, if you proposed your own project and a member of staff supported you as the advisor, it could be, you know, extremely beneficial to where you would end up at the end of the year. But what I'd say is that for some of the modules like PBL, there's definitely scope for proposing the project.
Great, thank you so much. We have reached the end of our fabulous hour. But before we go, I'd just like to say very best of luck to Kira. And do you know where you might go afterwards, Kira?
I don't quite know yet, to be honest. I have experience with industry and academics, so I do teaching as well. So
very good.
Yeah, I'm hemming and hawing whether to go academics or industry. So we'll see. We'll
see how you go. Well, one final question has come in. I'm sorry, guys, we're running over a tiny bit, but then I will let you off. After you graduate and get a job, how would you typically work? Would it be similar to the projects, as in there would be a team that would work on projects together? I suppose, yeah. Very easy.
Yeah,
great question, though.
I don't know if Kira can chime in after as well, but I think with an awful lot of the systems now, like they're so complex that there's very few people that could actually complete, like in our case, if you look at a base station, like a mobile phone base station, and that has to connect to a network, and there's so many different protocols that have to be kind of adhered to, that to actually achieve something like that is extremely challenging and would require kind of like really close teamwork. The same with some of the latest chips from Intel. You know, there's teams of people, armies of people even, you know, working to deliver those products. You might have cases where you could be a technical lead in a small company where you're doing IoT sensors and you just have to develop one bin sensor and you've got an off-the-shelf solution for the wireless. You might be able to work on your own and deliver a product that way, but yeah, what I'd say is that you probably can choose a career or a job where you could be either or. You know, I don't know, Kira, if you...
Yeah, in my experience, it's always been part of a team. So it's been a collaborative effort in most cases. So
great. Thank you, guys. Something that just popped into my head, but I suppose because there is no official date yet for the results of the leaving cert, we can't really give a date for the last chance maths exam. So I was just going to say, for the leaving certs here this evening, very best of luck. Maybe keep an eye out on the website for notification of the last chance maths exam, which I assume will be going ahead this year as in every other year for your H4 in your maths. For those of you who might be TYs or 50 years, or maybe parents of TYs and 50 years, or guidance counsellors, I know that Deirdre dropped the link into the summer school. And if you click on it, the timetable and the schedule is there. So definitely worth coming along and doing the summer school day and the engineering side of things. I want to thank you all very much for taking the time out this evening to chat to us. It's so interesting. I always learn so much, honestly. I look forward to MU Live. Sir, to Dr. John Dooley, soon to be Dr. Ciara MacDonald, Deirdre Carroll in the background, my colleague, and to everyone who has joined us here this evening. Just, I suppose, mention again that we have been recording the session. It will be available on mu.ie/MU Live if you pop that into your Google search tomorrow. I know Deirdre works hard on it in the morning, so it definitely be there for the afternoon. So any questions, you can pop them to admissions@mu.ie or electronic.engineering@mu.ie. Did I get that right, John?
Yeah, electronic.engineering, yeah.
electronic.engineering@mu.ie. Fantastic.
Perfect.
Thank you so much, guys.
Thanks a
Take
million.
care.
Best of luck,
Enjoy the
everybody.
summer and best of luck in your exams. Bye.
Bye.